and practice for comparing simple and compound interest. So I'm going to show you how we can solve these problems, and then you're going to hopefully take the post quiz by yourself and complete that. So we're going to look at number one. Liam invests $5,000 into an account that pays 2.5% compound interest annually. He uses the expression principal times 1 plus the rate with an exponent of t to find the total value after however many years. What is the total value after 3 years? So first we want to make sure we have everything in the right place. We know the amount of money we put in is the principal. So in each of these we should be replacing P with 5,000. So far that looks good, this looks good, this looks good, and this looks good. Next, we're going to want to look for the rate. So when I'm looking for the rate, I'm going to see right here that it's 2.5%. So when I'm putting the rate, I know that it has to go right here, right after the plus 1. So immediately I can see that this one is wrong because this has the rate as 3, and this is wrong because this has the rate at 3. Now one of these is going to be right, but we can see they look different. Are we going to leave the rate just at 2.5? So no, even though that this has a decimal, it's not a decimal yet. Because it has a percent sign, that makes it a percent. So the way we're going to do this is we're going to go over 1 over 2. And in this blank spot, we're going to have 0.025. So our rate should be this one right here, 0.025. And this T is going to stand for our years. And how many years did we have? We had 3 years. So it's not even asking us to solve it. It's just asking us to locate which one of these has the pieces in the right part. So we knew that the 5,000 was right for all of them. But immediately we could see that only these two had the years in the right place. But then we had to figure out, what is the rate going to look like? Do we leave it at 2.5? No, we have to turn it into a decimal, over 1 over 2, so it should be 0.025. So now we're going to do the same thing we've been working on when finding these interest rates, but we're just going to follow along. So first off, we're going to look at Janae, and she has option A. She's going to invest $10,000, so her principal is $10,000. She's going to do 7.14% simple interest. And we're going to have to use each of these to find out the different years. So I'm just going to worry about option A right now. And option A says simple interest. So when I click on it, it's going to tell me I equals PRT. Alright, so I'm going to go ahead and close that out, but I know that simple interest is going to be I equals PRT. So I'm going to rewrite that right there. So the problem is, whenever I do this formula, it's going to give me the interest. And the interest is how much the account goes up. But what it's asking for is how much is in each account. So we're going to go ahead and enter this into our calculator. So we know that for option 1, we have $10,000 principal. We're using simple interest, so I'm going to do times. Now how am I going to change 7.14? So I know what I'm going to do is I'm going to go over 1 over 2. So it's really going to be 0.0714. Times 0.0714. And first we're going to find out this first one, where the years is 3. So times 3 years. That's going to give us 2,142. And I don't see that option anywhere on here. But remember, this formula is just giving us the interest, or how much it grew. So if we started at $10,000 and it grew by 2,142, well then at the end of 3 years it should be at 12,142. And now we're going to do the same thing, except we're going to replace the 3 years with 15 years. So we're going to take our $10,000 principal. Our rate is going to stay the same, 0.0714. But now we're going to have 15 years. So once again, this simple interest formula only gives us the interest, or how much it goes up. So we know that if we started at 10,000 and it went up by 10,710, when I add those two together, I should get 20,710, which will be right here. So now we're going to solve option B. And option B says compound interest. So we're going to look at that formula again. All right, so I'm going to close it out. I'm going to write the formula for compound interest. And the formula is going to be the total amount is going to be equal to the principal times 1 plus the rate with an exponent of however many years. So we know that our principal is going to be $10,000. We know we're going to have 1 plus, and now our rate, we're going to go over 1 over 2, so 0.0596. And we're going to have an exponent of, well, it depends on which one we're doing. On the first one, for 3 years, we're going to have an exponent of 3. On the second one, when we do it, we're going to have an exponent of 15. So we're going to go ahead and enter these into our calculator. So we have our $10,000 principal, parentheses, 1 plus 0.0596, and we're going to do our exponent of 3 years. So we're going to get $11,896.70, which is about $11,897. And lastly, we're going to go ahead and do the same thing, but instead of having a parentheses, or instead of having an exponent of 3 years, we're going to go ahead and delete this, and we're going to make it an exponent of 15 to see what happens after 15 years. After 15 years, we should have $23,830.30, which is this option right here. So when we go ahead and check our work, it's going to come out as correct. So now we're going to go to question 3. So it's the same person using the same rates. Janae has $10,000 to invest, and she is considering 2 investment options. Option A pays 7.14% simple interest, and option B pays 5.96% interest compounded annually. So these are just things we need to know. For an investment earning simple interest, the interest is applied only to the principal. It's going to ask you this question a million times. You guys need to know it. So it's simple. It's only to the original amount. Now compound interest, it's to the original amount and what it earns. So now we're going to look here. If Janae wants to invest for 15 years, which one should she choose? So she's going to choose the one that has more money. So 20,710 or 23,830. She's going to choose option B. And why is she going to choose option B? Because it's going to have a greater value. She's going to have more money. All right, so we can go ahead and practice. So Jennifer invests $7,000 into an account for 12 years that pays compound interest. So here's our formula for compound interest. What will be the total value of the account after 12 years if the interest rate is 1.6%? So we're going to replace our principal. We have $7,000. We're going to put parentheses 1 plus, here's our rate. It's, even though it has a decimal, it's not a decimal because we have a percent sign. So we have to go over 1 over 2. So what this is going to be is 0.016. And our exponent is going to be the years, which is going to be 12 years. So we're just going to go ahead and use our calculator. I'm going to clear it. We have 7,000 times 1 plus 0.016 with an exponent of 12 years. When we click enter, our total amount is going to be $8,468.81. So right here. All right, so we're going to be looking at the same question again. Interest is applied to each year only to the principal for an investment earning simple interest. So only to the principal is simple interest. If it's applied each year and to every other year based off the stuff that it's earning, that will be compound. All right, so we're going to be doing the same thing where we compare two of these options. Jess has $7,500 to invest, so here is our principal. Option A pays 3% simple interest, and option B pays 2.75% compound interest. What will be the value of each at the end of 15 years? So first, let's do option A. We're going to work with simple interest, which is going to be P times R times T. So our principal for option A will be 7,500 times our rate. So this is a percent. We need to turn into a decimal, so over 1 over 2. We're going to have 0.03 times our years, which will be 15. So we have to remember that this is simple interest, so what this is going to come out to is just the interest. So we're going to go ahead and solve this and find out how much interest this account will get. So 7,500 times 0.03 times my 15 years. And that's going to give me 3,375. Now that's a problem because I don't see that option anywhere for answer choice A. But I know that this is just the interest. This is just how much the account grew. Now I'm looking for what is the total value of the account at the end of this time. So if it started at 7,500 and it grew by 3,375, we're going to combine those. And we know at the end of 15 years, the account is going to be at 10,875. So we know it's either going to be this option right here or this option right here. But now we have to find out what option B will pay. So our principal, we're just going to go ahead and plug this in. So our principal is 7,500. So now we're doing compound interest. So I'm going to have 1 plus, and the way I'm going to write 2.75% over 1 over 2. So 0.0275 with an exponent of 15 years. So I'm going to have $11,266.50. So the one that matches will be option this corner one right here. Alright, so once again, we're not even really looking to solve this problem, we're just trying to make sure everything's in the right place. So this is compound interest. I'm going to do this backwards, and first I'm going to look at the years. So I know the years is going to be 10 years, and I know the exponent for years goes right here at the end. So I know that this little t should be replaced with 10. So immediately I can check here, that looks okay, and this one looks okay, but these ones on the bottom are wrong. So I know my principal's in the right place on both of them, but now I'm going to look at the rate. The rate here says 2.15%. Let's figure out what this is as a decimal. So even though it has a decimal, it's still a percent because it has the percent sign. So we have to move the decimal over 2 spaces. So over 1, over 2, it should be 0.0215, which would be answer choice, this top right one, 0.0215. So we're going to be doing the same thing on this one. We're going to be finding simple interest and compound interest, and all we're going to do is we're going to change the years for each one. So first we're going to start with option A. We have $20,000 times, we have 3.6%, so over 1 over 2, we 0.036 times 3 years. And that, or sorry, 5 years, and that'll give us, imagine that's a 5, and that'll give us the interest for 5 years for option A. So we have our $20,000. We're going to multiply it by 0.036, and we're going to multiply that by our 5 years, and that's going to give us $3,600. I don't see that as an option here, but I know that this is just the interest. So if I take the $20,000 I started with and add in the $3,600, I'm going to have $23,600. Now I'm going to do the same thing, but instead of replacing it with 5 years, I'm going to replace it with 20 years. So now my interest, or how much it grows, is going to be $14,400. So if it started at $20,000 and it grows $14,400, I'll have $34,400. Now I'm going to do the same thing with option B, but now I'm doing compound interest. Alright, so I'm going to have my principal, which is going to be 20,000 times 1 plus 0.036 with an exponent of 5, and then I'm going to do it again with an exponent of 20. So I'm going to clear this out. So for 1 year, it's going to give me when I do the formula for 1 year, it's going to give me 20,720. So I'm going to go ahead and replace that. And now I'm going to replace the exponent with, instead of 1, I'm going to replace it with 20 years. That's going to give me 40,571 and 90 cents, which is about 40,572. So I'm going to check this and go on to the next one. And so lastly, we're going to take a look at this. If Kristen wants to invest for 20 years, she should use option B because she's going to have $41 more. So she's going to end up having a bigger amount than she would on, sorry, this one says for option for 20 years because the investment will have a greater value. If she wants to do 2 years, we're going to look at which one she'll have more. She should use option A. And for the same reason, because she's going to have more money, her investment will have a greater value.